just a bit more details in every aspect we've told in the first part. Okay, so let's go through this bar. What is this material itself, and what are composite materials actually themselves? What do they consist of, and all the structures and all the things. So first of all, every composite material around the world consists minimum of two things. First is a binder, and the second one is reinforcement, or sometimes filler. Every composite material in the world. And there are several types of composite materials. 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional materials. So we're not going to go super deeply into this agenda, but the idea is that, let's talk about the concrete itself. We can tell that concrete consists of two things. First thing is gravel, stones inside, and then kind of mixture of cementum with the sand and with the water. So, and it fills all the gaps between your stone. So it's like a glue which can hold major load of your composite material, because concrete is the best known composite material ever. For more than 4,000 years people use these materials. And reinforcement here is your stone, and the binder is your cement. So the major thing of this material is that if you separate this material by components, you will never get the same properties as when they work together. Let's say cementum, if you will use, let's say, block of cementum and compare it with a stone here, and you start to press it on it with the same, with some force, you will see this is cementum and this is stone. You will see that stone will, will hold much more, much more huge load compared to cementum. This is obvious. But the problem is that you just can't, somehow pile the stones in shape you need, because let's say you need some super shape like this. So how are you going to do this with stones? You can't. So that is why we need cementum to hold stones in proper shape and to distribute load between stones. That's it. In this way, this structure will work perfectly. So we can make the analogy of concrete we use every day with our material. With our material we use here. So here we use two things. First, we use reinforcement. In our case, reinforcement is continuous fiber. Continuous fiber made of glass. The interesting thing here that this is not just the glass we use, let's say, every day. This is special glass, of course, with a bit different chemical and physical properties, but anyway, everyone knows that glass is brittle. But if you make this super thin threads of this glass, so this material totally changes its properties. Let's say if there is a thick glass, you can easily break it. But if it's super thin, you can't break it. You can even make the knot or something like this. So the diameter of this one thread is 0.024 millimeter diameter. You see, so it's less than one hair on your head, less than this. So, and you can imagine that this is glass, but the tensile strength of this glass is 2006, 2007 megapascals, which is huge, and this is just a glass. Okay? Then another component is, which is binder. For us, it is, we call it resin actually, but to be honest, this is a mixture of several components which just combines, let's say, our threads between each other. So they just hold it. And the purpose is the same, just to distribute load between the threads. Because you know, this tiny thread can be break very easily. But once we get them in a, let's say, in a bar like this, so the ultimate stress just rises significantly because we multiply every small, let's say, thread up to all the diameter of this bar. That's it.